Welcome to today's math class. Today we have a nice algebra equation before us here. A simple one at that. Now the question read s to the power of 4 minus 4 equal to 0. On this channel, I have solved a similar question of this kind. Kindly scroll down and you will see the question, but it's a bit tougher than this, okay? So if you're new here, subscribe if you've not subscribed so that you get our math videos whenever they are released. Okay, so let's go into today's challenge. The question is s to the power of 4 minus 4 equal to 0. So how do we get all four solutions to this challenge? And in this challenge, I'm going to test all the four roots to confirm or to show that the solutions are correct. So let's take our solution. All right, so the question, we said x to the power of 4 minus 4 equal to 0. So the first thing we do here is to remember some of our algebraic identity and some of the formula in algebra. Now we can rewrite this because this is a perfect square, and we can also rewrite this power here. So how do we rewrite this? We can write this as our x to the power of 2 bracket close or to the power of 2 minus 2 close bracket or to the power of 2, everything equal to 0. Now, so what do we do next here? Seeing 2 here, and a minus sign here, then what comes to mind is difference of 2 square. Remember that if we have x squared minus y squared, this is equal to our x plus y close bracket x minus y. Remember this formula? This is what we call difference of 2 square. So what we have here now is similar to this. So x here is our x square, y here is our 2. So if we bring this formula in here, we can rewrite this expression as, or this now implies that our x squared plus 2 close bracket, then bracket our x squared, then minus 2 close bracket equal to 0. So this expression is the same thing as this. So what we do here, we can equate this to 0, right? So this will now give us here x to the power of 2 plus 2 equal to 0, or x to the power of 2 minus 2 equal to 0. So we have two cases here now. So let's take case 1. So we have here case 1. Our case 1, we have our x squared plus 2 equal to 0. So not much work here. All we need to do is just to send these two to this side. So we now have x squared equal to minus 2. So kindly take the square root of both sides. They will also take the square root of this. And remember, once we take the square root of this side, we introduce plus minus. So this leaves. So we now have x is equal to plus minus the square root of minus 2. Again, remember that the square root of minus 1 is equal to iota. Remember this? Okay. So we can bring in minus 1 from here, or bring out minus 1 from here rather. So if we have this, then we can rewrite this as our x will now be equal to plus minus the square root of 2 iota. Right? Good. So we have two solutions from here. So we have here x1 is equals to the square root of 2 iota, and x2 is equals to minus the square root of 2 iota. So we've gotten two roots from our exponential equation. So let's keep this. Now let's go to our case 2. Look at our case 2 here. So case 2, let's write our case 2. Case 2. Question is x squared minus 2 equal to 0. Again, we send this to this side. So this will give us x squared is equals to positive 2. And because we are looking for just x, we take the square root of both sides. Again, we take the square root of this, we equally take the square root of this, and introduce our plus minus. This leaves. So we have our x is equal to the plus minus the square root of 2. So we are now having our x3 is equal to plus root 2, and our x4 is equal to minus root 2. All right, so we have this as the root solution. Which is this to this nice exponential equation. But what to do a simple check to know whether these roots are correct or if they will satisfy this original equation. So let's rule out and check. Okay. So check here, check. So let's check. All right, so from our two solutions here, now first solution rather, let's take the positive one first. Okay, these ones. So the first one is root 2. So x3 now. So we're taking this as our case 3. Okay, we have our x is equal to root 2. So what is our equation? Look at our equation here. So let's bring in our equation, which is x to the power of 4 minus 4 equal to 0. So we can now put this in place of this. So we have root 2 all to the power of 4 minus 4 equal to 0. Root 2 can be written as 2 to the power of 1 all over 2 or into 4 minus 4 equal to 0. Then we can use this to divide this. Here we are left with 2. So we now have 2 to the power of 2 minus 4 equal to 0. So we now have here 4 minus 4 equal to 0. So we are going to have 0 equal to 0. So this shows that the root x equal to root 2 satisfy the first equation, the original equation, which is this root. So let's go for this now. So let's take this as our case 4, which is root 4, where we have our x equal to minus root 2, right? Good. So our equation again is s to the power of 4 minus 4 equal to 0. So we put in root 2, okay, minus root 2 all to the power of 4 minus 4 equal to 0. Then we can rewrite this again. So this will now give us minus your 2 to the power of 1 all over 2 all to the power of 4 equal to 0. So we use this power to multiply everything we have in here. So we have to multiply minus into 4 places. That is to say, minus times minus, that is plus, times another minus, that is minus, times another minus, that is plus. So this minus will change to plus, which is positive. Again, we're going to come up with 2 to the power of 1 all over 2 times 4 all over 1 minus 4. Oh, sorry, I didn't include minus 4 here, please. Here is minus 4. Pardon me, please. Okay, equal to 0. So everything equal to 0. This one, this here, 2. So we're ending up having 2 to the power of 2 minus 4 equal to 0. So we have here 4 minus 4 equal to 0. So we have 0 equal to 0. So this shows that the fourth root x minus 4 equal to minus root 2 is also correct. Case 1, which automatically root 1, where we have our x is equal to root 2 iota. So the question again is x to the power of 4, right? Minus 4 equal to 0. So let's quickly substitute. We're going to have here root 2 iota all raised to power 4 minus 4 equal to 0. Now, we have to use this power to open up everything here. So the first thing we have to do here is what is iota to the power of 4? Now, let me quickly give you a check into this. Iota to the power of 0 is equal to 1, because anything to the power of 0 will give us 1. except 0. 0 to the power of 0 will not give us 1. So iota to the power of 1 will give us minus iota. Are you learning something here? There we have iota to the power of 2. This will give us minus 1. Okay, then iota to the power of 3. This will give us minus iota. And iota to the power of 4. This will give us positive 1. So if you are familiar with this, then we can go ahead and solve our math challenge here now. So coming back to this place here, so our iota to the power of 4 will give us 1, like we've established here. So the whole of iota here will give us 1. So again, we can rewrite this. So this will now give us 2 to the power of 1 all over 2, or to the power of 4 minus 4 equal to 0. So this 2 here 1, 2 here 2, so we now have 2 to the power of 2 minus 4 equal to 0. So we have 4 minus 4 equal to 0. So we have 0 equal to 0. This is also proving again that the square root of 2 iota satisfies the original equation. So let's try the last one, which is case 2. So we have here case 2. And what is case 2? Case 2 says that our x is equal to minus the square root of 2 iota. So let's quickly do our substitution again. So we have here your x to the power of 4, okay, minus 4 equal to 0. So if we quickly replace this, we have here minus 2 iota all to the power of 4 minus 4 equal to 0. Again, this 4, we multiply this minus sign into 4 places, and this 4 we multiply this one into 4 places. Again, remember what we've established here. Okay, so automatically here we give us positive 1, and here we also give us positive. So we are still left with our root 2 or to the power of 4 minus 4 equal to 0. So again, we have 2 to the power of 1 all over 2 times 4 all over 1 minus 4 equal to 0. So end up here 1, here 2. So we're going to have here to be 2 to the power of 2 minus 4 equal to 0. So we have 4 minus 4 equal to 0. So 0 equal to 0. So this shows that all the roots, the 4 root we calculated for, which is this x1 is equals to this, x2 equals to this, and x3 equal to this, x4 is equals to this, satisfy the original equation, which is this. All right, so if you learned something from this nice exponential equation with the check, then give the video a thumbs up. And if you have a better way of solving this, then drop it in the comment section. Remember, we love you here at Math Prowess. Stay blessed. Bye. Until we come your way again. Stay safe.